Hi, I'm Ahmed Daud, and in this particular session, I am going to summarize the whole module of non-parametric model. So we have started from the discussion of the difference between parametric and non-parametric models, and we have seen that parametric models are models that assume some particular assumption, what type of relation between inputs and outputs. But non-parametric models don't take any type of assumption about the relation between inputs and outputs. We have started from the non-parametric model, one of the non-parametric model, which is decision tree. We have followed that model in the whole module. Okay, we have discussed a lot of aspects of that model. We started from the discussion of the what type of algorithms are available or can be a decision tree can be built by using what type of algorithms. Then we have seen that the cart algorithm is one of the powerful or is also implemented by the sklearn. So we have followed that cart algorithm in the whole module, and we also have implemented the decision tree by sklearn. Then we moved on the part of impurity measures. Regarding entropy, you are already familiar. So I have done a lot of discussion regarding the Gini impurity, which was the new for you, and information gain is a little bit just a little bit different from the entropy, and there is a just one difference in the formulation. Then we moved on the classification problem, how we can implement a cart decision tree if we are facing some classification problem. We have discussed that by an example, the whole process, and then we also have uh, code on the Jupyter notebook. Then we moved on the part of regression problem, and we have seen that there is just a one difference between regression and classification process of cart. The difference is the criterion, or you can say impurity measures. In the case of classification, we have different type of impurity measures like entropy, log loss, Gini impurity, information gain. But in the case of regression, we have as we are facing the regression problem, so we have different type of measures like mean square error, squared error, mean absolute error, and Poisson error. Then, after the discussion of CART and classification and regression, we come to know that we became familiar that the whole process for the both type of cases is the same. Just the difference is in between the imperative measures. If we will learn classification process by card, the whole process, then we will be able to do the regression also, because the hyperparameters are also same. Just one hyperparameter is different, which is criterion, and we also have discussed that. Then we moved on the part, and we have seen that one of the major challenge in the decision tree implementation is overfitting. It can easily lead towards the overfitting, and then we have started to discuss how we can avoid that overfitting. There were two approaches we have discussed: pre-pruning and post-pruning. We started from the pre-pruning part, and we have first of all we have to uh, learn the hyperparameters. So that's why we have a lot of discussion on the hyperparameters of decision tree that are listed by the sklearn. And then also we have discussed the cross validation, because multiple times we have seen the cross validation in the grid search part. So CV is equal to 5, a lot of times we have specified. So that's why I want to elaborate here the intuition behind that. We also have discussed that. Then we moved on the part of the case study that we have done in the case of logistic regression. The same case study I have followed here, and we have tried to do some pre-pruning or to build a pre-pruned decision tree on that particular data set. Then we moved on the part of post-pruning, how the process of post-pruning can be carried out. We have started from the example, and we have a deep understanding how the process is carried out. Then we moved on the part of the what are the intuitions behind the cost complexity parameter and cost complexity measure. We have discussed that particular session by comparing with the regularization technique that we have already studied in the case of linear model. Then we moved on the part of post pruning again, and we here implemented post pruning by sklearn on the iris dataset. Then we moved on the part of the similar same case study that we have used in the case of pre-pruning. Here we have tried to build a post-prune decision tree on the same data set, and we have compared their scores also. Then we have seen the time complexity. What is the time complexity of the training process and the prediction process of the decision tree? At the end, we have seen advantages and disadvantages. A lot of advantages, like the decision tree, are quite powerful regarding the capturing of patterns. But again, a drawback that it can lead to towards the overfitting. It is quite simple and quite easy to interpret decision trees. It can capture any type of patterns, but again, it is unstable. It is very sensitive to the small variation in the training data set. Then we have seen extrapolation. It cannot extrapolate the data points and the patterns. So we have also seen that in the case of regression problem, so our decision tree structure or the formulation, or you can say decision boundaries of the function of decision tree is piecewise constant approximation in the case of regression problems. But in the case of classification problem, instead of taking the mean of the samples that at a particular leaf, we actually calculate the majority samples of some particular class that are present at that particular leaf. Okay, so piecewise constant approximation in the case of regression problems. Regarding the practice projects of decision tree, as we have followed the whole process with respect to classification. So the regarding the classification problem, I have listed here the one practice project. You can go through that. And regarding the regression project, you can follow the same project that we have discussed in the case of linear regression, the case study and the practice project. Both you can use, and you can implement the decision tree regressor on both data sets. Okay, because already you are familiar with that problem statement. So this was all about the summarization. I want to here sum up the whole process that we have done till now in the non-parametric model. You have seen that how the non-parametric model, uh, you can say, without taking any assumption between inputs and outputs, you can build a model, and you can train the model, and you can predict the some prediction or classification or regression by using non-parametric model. Okay, without at the start you have not any assumption, mathematical assumption between inputs and outputs. One of the recommendation that there is a very good book, Hands-on Machine Learning with Scikit-learn, TensorFlow and Keras by Ron. It's a quite good book and it's quite famous. The third edition of that book is published in October 2022. So you can also get that edition. You should read that along the way. We are discussing the a lot of breeds of machine learning. It's quite interesting, quite helpful. So you should have a look on that also. So in the next module, we will discuss another breed of machine learning, which will be ensemble learning. So for now, best wishes for you. So